EcoCosm is a design build energy efficiency firm, energy efficiency and decarbonization. We work with commercial real estate owners and corporate owners, anywhere from single buildings to nationwide portfolios. So we're sort of sleeves up, rolled up, diving into the details, coming out of sort of energy efficiency and leveraging that as a way to really make strides early on towards decarbonization, and then implementing both energy efficiency and HVAC upgrades that will get a building or a group of buildings to net zero. So next slide, please. So why decarbonize now? There are a lot of things going on, as Brendan kind of mentioned, in the marketplace. You have corporate net zero targets, and people worried about stranded assets and CREM kind of modeling, when those things are going to happen, and then how are we going to meet our decarbonization goals that corporations are setting with, if you look at the right side of the slide, sort of higher vacancy, occupant demand for more efficient workspaces, and higher costs. So there are a lot of things kind of coming into play. You have lower revenue coming in and higher costs, and then all sort of in the mix of corporate emission targets and existing policies in place and developing policies. So commercial real estate owners are sort of in the middle of this crunch. And decarbonization is costly. It's not just a one-for-one replacement of a natural gas boiler. So there's a lot to think about, and it's key. It's really important to make it a staged approach. You need to be strategic about how you're going about it. Deep energy efficiency is kind of one of the first and biggest levers to lower your cost. It's also the lowest cost per metric ton of CO2 reduced. And it's important to plan for decarbonization upgrades at the end of equipment life. So next slide, please. So I kind of touched on this, but really staging the process, starting from your baseline and figuring out, what's the plan to get first to 2030. We're just almost 5 years away from that. And then to get to net zero beyond that. So you have deep energy efficiency is going to get you a long way today, and then planning for those larger investments to meet that next goal. Next slide. So a little bit of background about commercial buildings. Many of you are already familiar. But you're basically, you're looking, you have a commercial building, you're pumping heat in with the boiler and rejecting heat out through the cooling tower. So this is the way it's done. You have open loops, and we really can't do this anymore. And sort of in the middle of this graph in the oval, there are a lot of hours during the year where you have simultaneous heating and cooling, and you can take heat that would have been rejected to the atmosphere and repurpose that for heating in other parts of the building. So next slide, please. And then this is sort of an example of what it might look like. In this case, it's showing the boiler's removed. Probably don't want to remove the boiler right away, but again, you're basically transferring heat, and it's important to keep the boiler. This gives added comfort level to facility managers. When we tell folks, yeah, we're not going to take your boiler away right now, it kind of settles the conversation down. They're more open to, well, okay, well, how does it work when we add a heat pump to our building, and what are the technical details, and it kind of changes the tone of the conversation. So again, in this middle oval, you want to install heat pumps. You're going to take 80-degree condenser water, bump it up to 150 degrees for your heating hot water. And it's really important to do the energy efficiency work to reduce the heat load and to meet meet those building loads with lower heating hot water temperature. Typical designs out there is 180-degree water. So you're and heat pump technology can only right now meet that 140, 150-degree temperature. So it's important to do the work to be able to use the technology and have as many technology options available to you as possible. Next slide. So we're seeing a lot of poorly conceived designs out there. Designers and HVAC contractors sort of doing what they did before. Look, everything's kind of one for one. Your boiler is this size. We need to put in equipment that matches it, is the same size. Let's change out a natural gas boiler with an electric boiler. Besides the fact that that's, not code compliant, we're still seeing that, sort of as a conversation in the marketplace. So it's important to address that when, thinking about policies and really driving decarbonization. So here we have an example of a 1 million square foot portfolio at $20 a square foot. The cost to decarbonize, you're looking at a $20 million capital expense. And a 3 to 4 times increase in your operating expense, just by going in and kind of tackling things as they are today. So electric boilers, as I mentioned, not only are they not code compliant, but they're 3 to 4 times the cost to operate than a typical natural gas boiler. And a lot of the designs we're seeing are just one for one air source heat pumps, or stacking, getting your heat from the air and then bumping that up to maybe 120 degrees, and then taking that, having another heat pump in line, so you're having dual equipment to sort of do the service of one thing. Next slide, please. So the alternative is, you can cut your capital expense by up to half by really being smart and strategic about how you're decarbonizing, looking to decarbonize a large commercial building. Then first is, again, focusing on reducing through energy efficiency, reducing your operating expense. I've listed a number of strategies here that, you'd want to stack and apply to your building. And one point I really want to make is, it really doesn't make sense to consider a heat pump chiller, or you're talking about at least a $500,000 investment in equipment alone. So it's the equivalent of a Ferrari engine. And in a lot of cases, people are putting these in buildings with pneumatic controls. So the equivalent of a VW Bug, it's 1960s technology with a state of the art. And the 1960s technology is what's really driving the function of that state of the art technology. So it's important to focus on upgrading controls in the building. So next slide, please. So typical approach would kind of look at where all the on-site heat resources are, where you might have simultaneous heating and cooling. Is there a capacity on the electric side to do the decarbonization upgrades? What's the age of the equipment? Kind of running down through a checklist and identifying the strategies. And control, again, is you're implementing deep energy efficiency and getting control over your full HVAC system all the way down to the zone level. So you have insight and can see what's happening. Once you do that, you want to capture heat from everywhere and store it, and then reuse it later during your peak load times. And then, as you get further out towards 2050, any remaining residual, decarbonization that needs to happen, getting rid of, high CO2 refrigerants, that's what's going to happen at that last phase. And you're calibrating along the way, just making sure that the building's operating the way it should be. Next slide. So here is an example of what that might look like. typical building load profile. You have your heating load and your cooling load. And you can see in this case, you're meeting 56% of your annual heating load just by capturing the rejected heat, or the heat that would have been rejected from your cooling system. And then there's some additional strategies you can layer on to reduce your peaks even further. Next slide. So there's a myth out there. We hear it a lot. We're going to have to upgrade our electric service. It's not possible. It's too costly. Here's an example of a 250,000 square foot building in San Francisco. Your rated electric service is on the left-hand side, and on the stacked bar on the right-hand side, we take off a 25% margin off the top. So that's the gray bar. Moving down to the bottom, there's 500, or the 500 kW is the existing load, looking over the 10-year window, and then the gold bar is your added decarbonization load. So the purple is the amount of space, room that's still left after the building's decarbonized on your electric service. Next slide. And then another myth is, we have this size of natural gas boiler. We need to put in this size, same size heat pump technology or electric boilers, whatever it might be. Again, you have to look at the 10 years of data, at least 1 year. The more, the better. And in this case, you can see that the actual heat load on the building was significantly less than what the boilers were sized for. Then looking at efficiency, so this would be the third bar. You're taking out the heat load with efficiency, and whatever's left over is what you have to decarbonize. And it's not as much as you might think. Last slide. And again, I mentioned, being strategic. So, looking at when you're going to upgrade your equipment, and then having a plan as to what you're going to do and how does that move you towards your 2030, 2050 goals to decarbonize. You don't just want to think about one-for-one replacements anymore, even on the chiller side, because that's where you can capture a lot of the heat from simultaneous heating and cooling. And that's it. Thank you very much, everyone.